Hello everyone. In previous day I discussed about what is perfect square. Perfect square number. We can easily check which is not a perfect square number. We follow some tricks to understand which is not a perfect square number. We need to know all possible digit in unit place of the perfect square number. The last digit of any number or digit in unit place between 0 and 9. Perfect square number means a number can be expressed as a product of pair of same number. Product of pair of same number, that means if we take any example, so 12 into 12, that means 144 is a perfect square number. So 144 is a perfect square number, that means 144 can be written, 144 must be expressed as a product of two same number. So all here last digit is 2 and 2, then last digit of the perfect square number become 4. So first we see the all possibilities. So last digit of a number and last digit of its square, okay, or unit digit of its square. So here we get the all possible unit digit, all possible unit digit or unit place digit or one place digit or last digit of a perfect square number. So last digit of a number 0, that means it may be 1001520, this kind of number. Then what is the last digit of its square? So 0, because 520 into 520, then last digit becomes 0. If it is 1, then last digit, for example 5251, so last digit is 1. Similar, in case of 2, last digit is 2. In case of last digit is 4. In case of 3, it become 9. In case of 4, it become 6. Why? Because 4, if here's some number, if we multiply it, then last digit is 6. So last digit 6, 5, then 5, 6, 7 is 49, that means 9, 8 is 64, that means 4, 9 is 81, 1. So these are the digit, all possible digit in unit place. So we cannot get a perfect square number whose last digit is, here 2 is not there, 3, 7, 8. Yes. So if any number contain this one of these 4 digit at the last of the number, or if last digit is 2, 3, 7 or 8, then the number is not a perfect square number. For example, 8529758, it is not a perfect square number because last digit is 8 and 8 can't in the possible unit digit of a square number. Okay, so it is not a perfect square number, but it must be kept in your mind. If last digit is one of 0, 1, 4, 9, 6, 5, then it may or may not be a perfect square number, because if 12 because 12 into 22, so last digit is 4, but result is not a perfect square number. So if the last digit of a number are this, then it may or may not be perfect square number. But if the last digit is 2 or 3 or 7 or 8, then it is not a perfect square number. We can say directly it is not a perfect square number. And if the digit one of this from one of these, then we cannot say directly it is perfect square number. It may or may not be perfect square number, but in this case we say directly it is not a perfect square number. Next, I take two example related to example or question related to perfect square numbers, or related to square and square root, not perfect. Next, I take two problems based on square and square root or perfect square numbers. So first problem is find the greatest 3-digit or 5-digit perfect square number. Perfect square number, or which number added or subtracted from 99999 or 5-digit greatest number 999 to get a perfect square number. Perfect square numbers. Okay, perfect square numbers. These two questions are same because 5-digit greatest number is 99999. So 5-digit greatest perfect square number, it cannot be greater than this number, and if we add something then it becomes 6-digit number. So we subtract something from this number to get an perfect square number. So both questions have same meaning. Find the greatest 5-digit perfect square number, or which number subtracted from atho to get a perfect square number. Or here if we write which smallest number subtracted from atho to get a perfect square number, because if we subtract 99990, then the result is also a perfect square number. So we find the perfect square number nearest to 9999. That means as much as possible bigger. Okay, so it is better right here which smallest number should be subtracted from this number to get a perfect square number. And second question is similar but little bit different. Second question is find the smallest 3-digit perfect square number. Perfect square number, or which smallest number added or should be added to rate with 0 0 to get a perfect square number. Here also 3-digit smallest number is 100. If we subtract something, then it becomes 2-digit number. So we must be added with 100 some values to get a perfect square number. Okay. To understood the meaning of the question, I take one example. Which number added to 39 to get an perfect square number, and which number subtracted from 39 to get a perfect square number? So first we find the square root. Try to find the square root in division method. So 6 is the 36. So 3 is there. So which number subtracted from 39 to get a perfect square number? So here 3 is there. So if 3 is not there, then the number is perfect square number. So if we subtract this value from the given value 39 minus 3, then result is 36. So which number subtracted from 39? 3 is the answer. And which number added to 39 to get an perfect square number? So after 39, the perfect square number is 49, and before 39, the perfect square number is 36. So what is the in case of which number subtracted from the 39, we subtract this value, we get 36. That means a perfect square number. And in case of next number of after 39, the result is 6 plus 1 whole square. So 7 square, 49. So which number should we add with 39 to get an perfect square number? So 49 minus 39, 10. So 10 should be added with 39 to get an perfect square number. So in case of addition, we cannot add 3 to get a perfect square number. But in case of subtraction, we subtract 3 to get the perfect square number. Okay, and for second question, smallest 3-digit number. Okay, when I will solve that time, I will discuss about it. Okay, so we solve first and discuss solution or answer of the first question. Question number 1. So 5-digit greatest number is 99999. So we find first square root of 9999. Similar rule, we make pair from left side. So 9 is unpaired number. 9 is unpaired number. So first we write the number below the 9. So if we take 2, then here 4, 3, then 9, 4, then bigger. Okay, so 3 is perfect. For 3 3 is 9. So subtract, answer is 0, no need to write. Then 3 comes here with double. So here come 3 into 2, 6, and here one pair go down 9. So if we take here 1, then multiplied by 1. If we take 2, then multiplied by 2. If we take 2 here, then result is more than 99. So 1 multiplied by 1 and right here, so 61 1 is 61, and if we subtract, then it is 8 and 3, 99. Come here, next step again, here come double of 31. Double of 31 is 62. So 62 okay, 62. So if we take 8 here, so 8 is just 64, 8 is just 16, 8 4 6 8 more, it is not possible. So 6 to 6 6 6 is 36, 6 6 is 36, 37. Okay, it is nearest to this number. So 3 7 6 6 3 7 5 6. If we subtract, then the result is 143. So which number, if 143 is not there, then the number is perfect square number, so we must subtract 143. So for first question, what is the first question? I forgot. The first question is find the greatest 5-digit perfect square number. So what is the answer? If we subtract 143, then we get the answer. So answer of first question, answer the 5-digit greatest perfect square number is 99999 minus 143. So it becomes 65899. Okay. In another other way, we also get the answer. 316. If we find the square 316, then the result is also 6, because when we take that example, 6 6 30 33 36 and 3, if we subtract 3 from 39, then we get the result. If we find 6 square, then also we get the result. So if we find the 316 whole square, then we also get the result, or we subtract 143. Okay, so answer of or which small number should be subtracted from 999 to get a perfect square number. So 143 should be subtracted, or must be subtracted to get an perfect square number. Question number 2. What is question number 2? Find the smallest 3-digit number. So smallest 3-digit number, answer of question number 2, smallest 3-digit number 100. So 100. First make pair. So 1 is unpaired number. 1 1 ja 1. Oh, this is not possible for 3-digit, because 3-digit number is a perfect square number. So make it 4. In question also make it 4. So 0 0 0 0. Pair last 2 0 2 0. 3 3 ja 9. 1 double of 3 6, one pair comes here, so 1 1 61 9 39. What is the question? Find the smallest 4-digit perfect square number. Okay, make in question also it was 4-digit, otherwise 3-digit smallest number is a perfect square number. So what is yes, 31. So here we need smallest 4-digit perfect square number. We cannot subtract anything from 1000. If we subtract anything from 1000, then it become 3-digit number. So we must add something. So in case of addition, we need the next perfect square number after here, after 39, which one is the perfect square number? 6 plus 1 whole square. That means here the required number is 31 plus 1 30 whole square equal to 32 whole square. So 32 into 32, it is 4 6 6 12 3 3 19. So it is 1024. So the smallest 4-digit perfect square number is 1024. And or question, which number added to answer of the or, so which number added to 1000 get a perfect square number? So the smallest number added to 1000 is 1024 minus 1000. 24 is the required number, or 20. If we add 24 with 1000, then we get the perfect square number. Please everyone change that question. Write the question. Make it 4 and here 1000. Okay. If any problem, then you tell me later. Next thing is square root next thing is square root of a number which is not a perfect square. Square up to 2 dp or up to 2 decimal place, or correct up to 2 decimal places. Okay, in place of 2 you can write 3 also, then we find the answer in 3 decimal places. Okay, or you can write here another topic name, square root of decimal. Okay, for example we find square root of 4097. 4097 is not a perfect square number because in unit place there is 7. So directly we can say that 4097 is not a perfect square number. We find the square root of 4097 by division method. Since we have to find the square root up to 2 dp, that means 2 digit after decimal. So digit after decimal of the given number must be 4097. So 2 dp, that means in answer we need 2 digit after decimal. So in question we need 4 digit. Okay, because for 2 digit 1 digit goes here. Similar process. One thing, in case of decimal, after decimal pair go in this direction and making pair goes in this direction before decimal. So 9797. Okay. So 40, 6 6 is 36, 7 7 is 49. So if we take here 7, then it's bigger. So that's why we take 6 6 6 is 36, and if we subtract, then become 4 and 9 7. One pair comes here, and here double of 6 or 6 into 2, 12. Next, which value we take here? If we take 4, yes, if we take 4, then it is nearest to 497, maybe 2 4 4, then 6 9 4 4, yes, 496, then one here and one pair come here, and taken 4, we take 4 here, so here also 4. So next pair after decimal, so decimal goes here, so 100, double of, again we take double here, double of 164 is 128, and if we take 1 here, then it is 1218 multiplied by 1, and it is bigger than 100. So we need another pair, and if we take 2 pair at a time, then 10 we take here. Okay, only we can take 1 pair. If we take more than 1 pair, then we take 0 here. So 0 0, so multiplied by, okay, first we take value 8, 1288, 1288 into 8, 8 is 64, 8 9 9, yes, it is nearest to, so 8 here, so 9 9 8 8 8 4, then it becomes 16. So in answer up to 2 dp already come, so no need to find more. Therefore 4097 equal to how much? 64.08. It is not equal, correct up to 2 dp or 2 decimal places. Similarly, we can find the square root of decimal, because already we take decimal here. So for decimal, same rules. Okay. Next, I give some question about this